All right, so the OST is done. We're going to do some topics that we probably, if I were to design the course, we would have done back in chapter 9, but they're not on the OST, but yet they're important for Algebra 2, so we're going to cover them now, make sure you guys are ready for Algebra 2. And they're really important for pre-calc as well. So today's lesson, pretty easy, honestly. The next couple of days are pretty easy. We're going to do what's called special right triangles today. We'll finish it up tomorrow. Don't forget we have that special schedule tomorrow as well. We will be having a short quiz. It's on the Big Ideas Math site for this stuff. Not real long. It's just over one section, special right triangles. And then we'll do what's called law of sines, law of cosines, and then we're going to have a quiz over all 3 of those topics next week sometime. All right, so sum of the points, we haven't had any in a while. Short quiz this week, bigger quiz next week. All right, so we've got a couple triangles here. Let me preface this by saying not all triangles are special. Okay? All of you are special. Not all triangles are special. Okay? So, in the context of special right triangles that we're going to be talking about today, every triangle you look at, you need to ask yourself, is this a special right triangle? And we don't quite know what that is yet. But if I were to say, how many of the angles do you know in this triangle? Because we're going to classify special triangles by their angles. Do you know the angles in this triangle? I see a 90-degree angle. Do you know the other 2 angles? They're not written there, but do you know what they are? They got to be 45, don't they? Why? Good. It's an isosceles right triangle. If 2 sides are congruent, aren't the 2 angles congruent? Do you agree with that? And if 2 angles are congruent and we know they add up to 90, we all know they add up to 90, right? I mean, they could be 20 and 70, they could be 10 and 80, but no, they're congruent, they're both 45. Does that make sense? Now, just put that in your back pocket for now. That's not what we're doing on this one. We're solving for x. How did you solve for x? Pythagorean theorem? Good. So 4 squared plus 4 squared equals x squared. 4 squared and 4 squared is 32. Square root of sides. What does it mean, simplest radical form? Do you remember? It's been a while. That's not simplest radical form.
Oh, is that where
Anybody in the room remember? Page.
Is it where you have to find the common something? I don't know how to describe it. Make the tree.
Mm-hmm.
Yeah, the little tree.
So what are the factors of 32? Give me one pair of factors.
8 and 4.
8 and 4. So do you agree if I write 8 and 4, that's still under the square root? But 8 and 4 multiplied to 32. What else? A lot of people prefer to keep going.
2 and 4.
2 and 4 times, let's bring this 4 down, still, come on. Uh-oh. Pretend that's a square root symbol. 2 times 4 times 4 is still 32.
Oh, wow.
Someone's got a case on the Mondays. All right. Where was I? Okay. 4 and 2, and this 4 still comes. Okay. Now, here I'm going to do it the long way, and I'm going to show you what I prefer you do, since we're honors math students. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Do we all agree this is still 32, just written out in expanded multiplication form, right? Now, here's the deal. Quick refresher. What's radical 5 times radical 5? Okay, radical 25. It's fine. What's radical 7 times radical 7?
7.
It's 7. If you're getting decimals, you're missing a parenthesis after that first radical, okay? What's radical cat times radical cat? Cat. Do you agree? Do you agree?
Yeah.
Why? That's the definition of what a square root is, right? I mean, the square root times itself, it's like saying that number, I guess I really need you to listen. It's like saying that number is being squared, isn't it? A number times itself. Radical 5 times radical 5 is radical 25, but it's the same as radical 5 squared, and we know squares and square roots are inverse operations. They cancel each other out. Make sense? Are you with me? It's going to come really important. Now, your algebra teacher may have said some little saying, or I forget. Did they have any little story about this is a jail? Levi, let's just stop eating. All right. Question? Or what would you say? Huh? They got married, and what happened? I don't know these stories.
Then they left the house.
Okay, so this is the house. How many of you have heard a story about this? No? No story.
No.
Okay.
We definitely did.
Did your teacher have you circle pairs and bring them out?
Yes.
Okay.
Yeah.
Why?
Because that's what goes
To represent the pairs.
Because, listen, I need you guys to listen. We need to go through this quickly. 2 times 2 is 4 under the square root. But when you square root 4, you get 2, right? This is another pair of 2's. 2 times 2 is 4 under the square root, and the square root of 4 is another 2. Isn't there a 2 left under the square root? So the square root of 32 in simplest radical form is 4 times the square root of 2. X is 4 times the square root of 2. Does that make sense?
Yes.
Okay. Now, quick practice. What if you simplify a number and you get 3 times 2 times 5 times 5 times 3? What comes out? A 5, because that's 25 under the square root. Square root of 25 is 5. Anything else? 3. And there's a 2 left inside. This would be 15 radical 2. Do you all agree? Good with this? Now, here's what I want you to consider. What if I write this as, come on, 8 times 4? What if a student says, well, the square root of 4 is 2. Is that okay to not break it down into all the 2's? Yes and no. Why is it okay to say that the square root of 4 is 2 and take that out? Well, the square root of 4 is 2. But is this simplest radical form? No, they would need to do what? The 8 can still be broken down. And could they say, well, a square root of 4 is another 2? And that's 4 times the square root of 2. Is that okay? Yeah. So do you need to break it down into all the 2's and 3's and 5, all the primes? No. If you see a perfect square along the way, what if you get this? Is it okay, instead of going 8 and 2 and 4 and 2 and 2 and 8 and 8 and 4 and 2 and 4 and 2 and 4, is it okay to say, well, the square root of 16 is 4, the square root of 64 is 8, and I have a 3 left inside? Is that okay? I need you to be honest with me here. That is absolutely fine. That's actually what I want you to do as honors math students. You shouldn't have to break it down into all the primes. If you see a perfect square, square root it, take it out. Done. Done with that part. Okay? All right. Next one. 15, 20. What'd you get for the hypotenuse?
Hi, Mr. Westfall.
Good morning.
Do you get any extra, where do you keep your copies from Algebra 1?
Second file down right there.
Parker steals everything of mine.
Of course it is.
Never gives me anything. Alright. I just need one worksheet.
Sure.
You're good with that? I'll take those back.
Yep.
What we got here? Geometry?
Yep. Well, special rate triangles today.
All special rate triangles. Square root of 3/2, 1/2, that stuff?
We're gonna get to it.
Oh.
Yeah, for sure.
I don't want to spoil it. Spoiler.
All right. SPD Lab teaches CCP pre-calc. So you might have them in 2 years. Okay. All right. Anybody have them for Algebra 1 last year? Or honors Algebra 1? No. All right. Is 25 simplest radical form? Yeah, because guess what? You had the square root of 625. Here's the first thing you should try. Can I take the square root of this number and get a whole number? That's the simplest radical form. Should I do this first? Some people do. But what are you going to find out? Every number has a pair. Meaning every number gets to come out and there's a 1 under the square root. It's a whole number. Your mind should go back to the beginning and say, well, I could have just taken the square root of that number and gotten a whole number and be done with it. Make sense?
Yep.
Last one. What did you get for the hypotenuse? Or are we not sure about if it's correct in the simplest radical form? 3 times the square root of 2? 3 times the square root of 10. Let's see. 3 squared plus 9 squared equals x squared. We got 81 and 9. That's 90. Square root. 9 and 10. What can I take out right away? A 3. And I have to ask myself, not does 10 have any factors? Because 10 is not prime. It does have factors of 5 and 2. What's the question you should ask? Does it have any pairs, right? Does it have any perfect square factors, okay? And it doesn't. So 3 radical 10 is the simplest radical form. Are we okay with this? This is important so we can get ready for today's lesson, all right? So today we're going to learn what's called special right triangles. I want you to consider, why is a 45 degree, 90 degree, this is called a 45, 90 for short. Why is this special? Well, it comes from cutting a square in half diagonally. Does that make sense? I mean, if you have a square, all 4 sides are congruent, all 4 angles are 90. If you cut it diagonally, you get a 45, 90, don't you? And here's the question. Are we always going to have a side relationship between these 2 that are congruent and the hypotenuse? Well, I kind of spoiled it right there. The hypotenuse always has to be blank compared to the other 2 sides. Longer. I mean, isn't the diagonal of a square going to be the longest? Is it going to be longer than either of the sides? Right? The diagonal is going to be longer. We all agree with that, right? How much longer? Well, let's see if we can see a pattern. What if this is 3 and this is 3? What's the hypotenuse? Go ahead, try it. You don't even have to write it down. You can do it in your calculator. I don't care. In simplest radical form. What is it? 3 times radical 2? Did you guys get 3 radical 2 for that one?
Yeah.
Okay, let's do another one which is a little bit bigger. 4 and 4.
4 times.
4 times radical 2? 4 radical 2? forget. What's radical 2 again? About. Because I have 4 and 4, and then I multiply 4 times a number to get the hypotenuse. What's radical 2? Like 1.41?
Yeah.
So that longest side is like, it's not 4. It's not like the other sides. It's 4 times 1.41. Are you with me?
Yeah.
What is that? We're not going to write this as a decimal, but just for approximation reasons.
5.66.
And that makes sense, right? 4, 4, and then 5.66. Right? Let's do one more, then I think you'll be tired of it. Guess what we're gonna do? 7. I heard 5, so I was gonna be a jerk and do that. All right. Some people already had it done. 7 times radical 2. Do you agree? All right. Last one. I might have said that last time.
X.
I do? Where? Well, I know what that is, right? What is it? X times radical 2. This is a relationship in every 45, 45, 90 right triangle. The legs are congruent. The diagonal, the hypotenuse, is the leg times radical 2. Could we prove it? I'm glad you said yes. Ready? Emma said, let's prove it. I said, okay. X squared plus X squared equals question mark squared. What's X squared plus X squared?
2x.
What's X squared plus X squared? 2x squared. 2x squared. Right? Yes?
Yeah.
No? What's x plus x? 2x. What's x cubed plus x cubed? 2x cubed, right? What's an apple plus an apple? It's 2 apples. It's, right? Ready? Square root both sides. Wait a minute. What is question mark equal to? Shh. Oh, I see a perfect square. Guys, I've been using this word all period. What's the square root of 16? What's the square root of 25? They're perfect squares. Right? If you see a perfect square, square root it. What's the square root of x squared? X. Or could you do this? If you're that person. This is an arrow. Okay. What's x times x? Under the square root, it's x squared. When you square root it, it comes out as an x. Guess what I just did, Emma? I proved it for every x. Okay? For every x. How many of you get that? If I call those sides x, the hypotenuse is x times radical 2, based on the Pythagorean theorem and its simplest radical form. Okay, awesome. We just made a rule. I don't care how big the square is. The diagonal, the hypotenuse of that 45, 45, 90 is the side length times not times 2, times the square root of 2. And if you forget, isn't the square root of 1, 1? What's the next perfect square after 1? 4. What's the square root of 4? 2. So isn't the square root of 2 and the square root of 3 between 1 and 2? 1 point something. Let me say it again. If the square root of 1 is 1, and the square root of 4 is 2. The square root of 2 and the square root of 3 are between 1 and 2. Okay. So here's our first special right triangle. They use the letter n instead of x. All right? If you have a 45, 45, 90, whatever the sides are, the hypotenuse is the side length times radical 2. You guessed it. You guys have guided notes again. Next year, not going to be this way. Paige complaining about guided notes?
No,
No,
she was
I'm not.
defending. No, I didn't say that. Paige is a liar.
I've come to realize no matter what I do, someone's going to complain about it. People complain about guided notes.
You didn't sit there and go. Well, I'd rather not take notes. Take your guided notes and you're so happy. I like guided notes. I don't think Emma needs guided notes if she wants to.
All right, write this down. Write this down. It's a fill in the blank. All right. Because of the intro, I've already covered these as well. All right. So we're going to start here. Now, here's what I will say. You know what? I just anticipate confusion. I'm going to have to do one more intro because I don't. No?
That was not me. Like Paige says.
I think we can do it. I think we're okay.
Okay. Let me see if you know what to do then.
No.
This is their fault.
Write this in simplest radical form. Go. We'll ask Christiana for the answer.
No, don't ask me.
You said we don't need another intro.
I know.
Simplest radical form.
What?
Square root of 22.
5 radical 2.
Yeah, Anthony's got a cheating calculator.
Yeah.
Yeah, I did.
No decimals, simplest radical form. All right, how many of your teachers told you last year that you cannot have a square root in the denominator?
I'm sure you
I'm pretty sure you did.
I did not say that. Wait, you said it.
All right, because you guys don't care why, I won't explain why. I'll just tell you how to do it. All right? All right, how do we get the square root out of the denominator? There's no equal sign here, so whatever I do to it, I can't do to both sides. There's only one side. If I square it, let's say you have $1,000 in your bank account, okay? And I'd say, let's just square it. Did I change the value of your money? If I square $1,000, for sure. Can we change the value of this number? No, we can't because there's no equation. I can't balance another side. So whatever I do to it, I can't affect the value of it. What's the only way you can't affect the value of something? Multiplying it by, that's squaring it, by 1. But multiplying by 1 doesn't change the value of it, right? So how do you multiply by 1 and change the appearance of it? Well, you multiply by radical 2 over radical 2. Isn't that times a fancy 1? Isn't that 1? Isn't radical 2 over radical 2 1? Now, what does that do? You get, what's 5 times the square root of 2? Well, 5 radical 2. Can't combine them. They're not like terms. What's radical 2 times radical 2? What's radical cat times radical cat?
Cat.
What's radical 2 times radical 2?
2.
Just 2. Did we get the square root out of the denominator?
Yes.
Yeah.
Did we change the value of the fraction?
No.
This has the same value
I don't know.
as this. Type it in your calculator if you don't trust me. They have the same value. Make sure you use parentheses when you put a numerator or a denominator in, if it's got a square root. That's gotta be what, like 3 point something? Okay. And what's 5 radical 2 over 2? Same thing, right? This is simplest radical form. You cannot, some mathematicians will tell you, you cannot have a square root in the denominator. Okay? And we don't care why. Ready? I think we're ready now. All right. Find the value of x, write your answer in the simplest form. Now, here's the question you need to ask yourself. In a 45, 45, 90 triangle, there's only the isosceles sides and then there's the hypotenuse. Do you agree? How do we go from isosceles, short side, to the hypotenuse? Multiply or divide? Oh man. Do you guys want to keep doing Pythagorean theorem every time?
Yes.
How many of you are going to keep doing the Pythagorean theorem and do 8 squared plus 8 squared equals x squared?
You can, but there's.
Don't do it. Don't do it. You told me. You guys told me. If you have the short side, the long side is what? The short side times radical 2. Is that what you told me? Do I have the short side here?
Yeah.
Bless you.
8.
No, I'm not saying you're right or wrong. I just having one person answer is not very good.
Yeah.
Is 8 the short side or the long side, and how can you tell?
Short.
It's the short side. How can you tell?
Adjacent to the right angle.
Yeah, it's touching the right angle. If it's across from the right angle, it's the hypotenuse. Ready? Let's fill this in. If this is 8, this is 8, and this side is 8 radical 2. Please don't overcomplicate this, okay? And if you're trying to work way ahead, you're gonna get messed up, and I'm gonna say, hey, you weren't listening when I was going through some of the stuff that's gonna trip you up. All right. All right. Letter B. Is 5 radical 2 the short side or the long side? So how do you think I go backwards? I bet most of you just said, well, it must have been 5 because 5 radical 2 is the hypotenuse. Now, what if you're a student that's like, no, just I need like a process, I need an equation. Okay? Then if you have n, and n radical 2, do you agree we're trying to find the n side? Right from the notes? Or the x side? Don't let the x bother you, like whether it's x or y or p or f, it doesn't matter. Do you agree you could set 5 radical 2 equal to the n radical 2 side? This is way too complicated. Don't do it this way unless you're a person that's like, I really just need a process. Don't you agree that is the n radical 2 side? I could set 5 radical 2 equal to n radical 2 and solve for n. Right? How do I get n by itself? Divide by radical 2. Don't they cancel? What do you get? N equals 5. Okay? All right. Next one. Let's call this n. We only need to do it once because those are isosceles, right? What'd you guys get? Have you had a chance to try it? Well, what if we had the short side? We would do what to get the long side? We found a pattern. What do we do? Short to long. We multiply by radical 2. How do we go backwards? divide by radical 2. Isn't n equal to 12 divided by radical 2? Yes? Are we good with that? Kind of. It's not in simplest radical form, is it? How do we write this in simplest radical form? Get the square root out of the denominator. What do we multiply by? By what? Radical 2. That's a radical. Over radical 2. We have to multiply by 1. We can't change the value of it. That's a fancy 1. And so what do we get? Well, 12 radical 2 over 2. That can be simplified. Isn't divided by 2 cutting something in half? What's half of 12 radical 2? 6 radical 2's. Right? What's half of 12 x's? 6 x's. What's half of 12 radical 2's? 6 radical 2 is our final answer. How can I check this? To go from the short side to the long side, I can multiply by radical 2. Let's try it. What's 6 radical 2 times radical 2? 6 radical 4. Radical 4 is 2. 6 times 2 is 12. Perfect. It's magical, isn't it? Do you agree? Do you agree? Next one. Next page. I want you guys to try these. You get 5 radical 2?
Yeah.
And again, you can check it. You can multiply by radical 2, and you'll get 10. What'd you get? 7 radical 10. You have to remember your properties of radicals. Which you guys told me earlier, radical 5 times radical 5 was radical 25, which simplifies to 5. If you could multiply those, can't you multiply radical 5 and radical 2? You get radical 10. Now, you can't add, if you are adding different radicals, you can't say radical 5 plus radical 2 is radical 7. Doesn't work that way. Next. This is the more challenging one. I don't think you guys are going to have too much trouble with it if you pay attention and follow the rules. Now, here's the most important thing you do right now. On your guided notes, make sure you put the right thing in the right spot. I'm not even having you draw these like I typically would. Right, you guys have guided notes today. Make sure that n is across from the 30. The 2n is the hypotenuse. And the n times radical 3 is the medium-sized side, the one across from the 60. Do you agree n radical 3, and 2n are the three sides of this triangle? Okay. Now, I'm not going to go through the whole proof of it like I did in the 45, 45, 90. All right. I will show you where it comes from, but not yet. Do you agree these are written in order from least to greatest? This is so important right now. Okay. If you get stuck on a problem, the most important thing you can do to get kind of centered on that problem is to make sure you know that the n side is the shortest, n radical 3 is the medium, and 2n is the longest. In the 45, 45, 90, it was obvious. We had two sides that were the same, and then the long side, right? Now we have three different sides. How can we remember this? Well, look up here for a second. Isn't n 1n? Isn't it 1 times n? Isn't n times radical 3? It's more than 1n, because radical 3 is what again? 1 point. That was radical 2. Radical 3 is a little bit more than that. Maybe 1.7? Okay, so listen up. Isn't 1.73n more than 1n but less than 2n? So if you ever get stuck, because these triangles are going to get rotated and flipped and turned, you have to orient yourself and look at the triangle. You say, okay, 30 is across from the n. 60 is across from the n radical 3. Well, that makes sense. Isn't 30 the smallest angle? It's opening up to the smallest side. Listen up. 30 is the smallest angle. It opens up to the smallest side. 60 is the medium angle. It opens up to the medium side. 90 is the biggest angle. It opens up to the biggest side, the hypotenuse. Are we all good with that? That is so important to get yourself reoriented on these problems. Everybody good with that? Okay? So what if n is 5? What if n is 5? I'm not even going to rotate this picture on you. 30, 60, 90. Now, by AA similarity, any triangle with 30, 60, and 90 could be this big. It could be that big, but the sides are all proportional. I said if n is 5, what's this side right here across from the 30? 5. What's the side across from the 60? 5 radical 3. 5 times radical 3. And what's the hypotenuse? 10. 2 times n, 2 times 5. 10. Done. What if n is 20? Well, 20 radical 3, and 40. Make sense? Just scaling it up a bit. Back to the story. Where does this come from? It comes from half of an equilateral triangle. Isn't this equilateral? 2s, 2s, 2s. What are the angles of an equiangular triangle? 60, 60, and 60. That makes this angle 60. 60. Now we cut this one in half, so those are both 30. That's 90. And this, if the whole thing is 2s, isn't this 1s, 2s, and then Pythagorean theorem, you could do s radical 3 right there. I'm not going to do it right now. That's where it comes from. It comes from an equilateral triangle cut in half. Okay? That's why it's used a ton. All right. We're going to stop there for today. So your homework, I'm going to have to trim down a bit. Don't write this down yet. All right. The problems in red are for tonight. Here's what I'll say. Some of the problems we'll ask you to find the sides. Some of them might say have a square and say find the area, which obviously you'll need to find the side length. So you'll have to use the same similar concepts as to what we did in class to solve those ones. Tomorrow we'll finish up special right triangles and then have a quick quiz on Wednesday. Oh, by the way, the only 30, 60, 90 on here is one where I give you the S or the N side, the short side. It's an easier one. Don't have to do much work.